So we're gonna talk about electrostatic forces, and I usually like beginning with the streamable link. I didn't enable the audio. That was the problem. All right, so let's watch this video. The beginning is cheesy, but work with it. Work with it.
Take it easy, Dad. He never actually touched her. In everyday life on our world, on the scale of atoms, material objects never really touch.
Wait, sir.
Each atom has a tiny nucleus at its center.
So you're telling me if I punch someone, I never really punched them?
By the English definition, yes, you are punching someone. Punching is the physical force on another person by your hand. So by the English definition, you are indeed punching someone.
But if there's atoms between us, then that means I'm not really touching them. So if I could beat someone up, it doesn't count as me beating them up. It counts as the atom.
That's not the logic.
Thank you, sir.
We're not using that logic. We're not using this logic. That's very no.
Surrounded by an electron cloud of lines of force. As the atoms approach each other, the boys' electron clouds push away the girls. More than 99.9% of the matter of any atom is concentrated in its nucleus. The nucleus is surrounded by an electron cloud, which produces an invisible field of force and acts like a shock absorber. The configuration of the electron cloud determines the nature of an element. In the ordinary course of things here on Earth, the nuclei never touch. We have a sensation of touching, but that's really just our invisible force fields overlapping and repelling each other.
We're gonna watch it once more.
Take it easy, Dad. He never actually touched her. In everyday life on our world, on the scale of atoms, material objects never really touch. Each atom...
So again, guys, electrons are negatively charged. And electrons are going to repel each other, right? You have two electrons that come into, well, you try to get them together, and they're going to repel each other. Right? And when you're, because you're on a microscopic level, you're not actually touching someone. You're not physically coming into contact, right? It's that force that you feel, like when you grab a pen or you push a finger, right? You push on a table. The thing that you're feeling, right? Whatever force you're feeling is from this electrostatic force. It's from electrons repelling each other.
It has a tiny nucleus at its center, surrounded by an electron cloud of lines of force. As the atoms approach each other, the boys' electron clouds push away the girls. More than 99.9% of the matter of any atom is concentrated in its nucleus. The nucleus is surrounded by an electron cloud, which produces an invisible field of force and acts like a shock absorber. The configuration of the electron cloud determines the nature of an element. In the ordinary course of things here on Earth, the nuclei never touch. We have a sensation of touching, but that's really just our invisible force fields overlapping and repelling each other.
All right. Good, good, good. So again, so before, I mean, you can just do this poll, sure, why not? I'll write the link. All right, don't ask me. The answer is in the image, guys. Answer is in the image. I will use one of these polls as attendance. All right. What's it looking like? So the answer is in the image.
Wait, did you close it?
Yeah, it's locked.
I was
Don't worry
taking
about it.
I was
Don't worry about
going number one, but I had my headset on so I could hear you all along. I know you posted a link not too long ago. I literally just ran back inside, but I missed it because I had my headset on the entire time.
Don't worry about
I
it.
was hearing.
Don't worry about it. Okay, don't worry about it. So a proton and electron will attract, right? Opposites attract. I think you heard that before. It's like the most overused phrasing ever. Tell you right now that opposites do not in fact attract in real life. But for on the scale of protons and electrons, they do. All right. So protons and electrons do attract. Next one. Guys, make sure to answer this attendance poll. This is an attendance poll. All right, this is an attendance poll. You have 10 seconds left. Good. Oh my God. You know. Ah, man. You guys worried me for a bit. All right. So again, electrostatic force is the force that you feel when you're pressing on something. Right? When you come into contact with another object, and I say contact in the obviously English definition, it's the electrons between the table and your finger that are repelling each other. Right? That's that feeling that you feel when you push on something. So when protons and electrons get near each other, they exert an electrostatic on each other. Right? They exert an electrostatic force on each other. And a proton and electron will attract. Right? They're oppositely charged. Two protons will repel. Two electrons will repel. And the electrostatic force is equal to, it's on your reference table. So you go to your reference table. and you find out that yes, the electrostatic force F sub E is equal to this formula. I'll write it down. The electrostatic force is equal to F sub E K Q1 Q2 over R squared. What do you guys think Q1 and Q2 represent based on the image? What do you guys think? Please tell me you have electron or a proton. And I'm gonna be more specific now, even though it does say on your reference table, by the way, guys. It says Q. Q is gonna be your charge. Q will represent the electric charge of either the proton or electron. Right, that's what Q represents. So Q1, Q sub 1 means the first particle. Q sub 2 means the second one. Right? So it can either be a proton or electron. It doesn't really matter. And K, and you know that in the formula you see the letter K. The letter K represents the electrostatic constant, which is also on your reference table. The first page of your reference table says that the electrostatic constant K is 8.99 times 10 to the 9. So it's 8.99 times 10 to the 9 Newton times meter squared over Coulomb squared. Now, for the most part, you guys can always just round it to 9. It's not going to make much of a difference. We're not really dealing with precision here. Right? We're not dealing with groundbreaking physics. So it's fine if you guys round it to 9, which is what I'm going to do most of the time. I really don't want to input 8.99 into a calculator. All right. Any questions about this? Any questions about the formula? Any questions about what Q represents, what K represents, what R represents? We're going to go over practice questions on Monday. I'm sure if you've had a math teacher, I'm sure your math teacher is using something called Go Formative. I will try to use Go Formative now because essentially I am a math teacher. I might as well be. So I am going to try to use Go Formative. I think I watched another physics teacher is using it. I was watching her do it. And I was like, wow, this is good. I get to see you guys doing work. It's almost like I'm in an actual classroom. It's almost like I'm.
Are we really gonna use Go Formative?
Yeah, I will use Go Formative. Oh. It's gonna be great. It's gonna be great for me. I'm not sure about you guys, but it's gonna be great.
Yeah, it's gonna be amazing.
Yep. Glad you agree. Guys, have a great weekend. There's no homework. All right. There's no homework. Have a great weekend. See you guys on Monday.
I think you're muted, by the way.
I'm definitely not.
I think you're muted.
No, I'm not. I'm not muted. I'm not muted. Bye-bye, guys. You're not getting me. There's literally nothing on my screen that tells
you're muted.
I'm talking, it literally gives me the icon that I'm talking. You guys are messing with me. Have a great weekend, guys. Bye-bye.